So, sorry, problem number 1, A, B, and C. You already have really good notes on solving problem number 1, A, B, and C. Because it was in the pink packet that I gave you recently. And we had the extra credit assignment. That's all these problems are. So you already have good information on that, so I'm not going to write anything down on those 3 problems. Questions? The individual help can come see me. Today, new thing. I'll send out a text next period. After school from 2:30 to 4:30, we will be playing the official game. And the way the game is played is I put problems on the board. We'll start with multiple choice. The class answers them, we correct them, we answer questions about them, and we pay pebbles for correct answers. So it's a way to get extra credit, but it's also a way to get better and better at preparing for actual multiple choice questions on the AP test. The game also works well because while the room is working problems, if anyone needs individual help, they can sit with me in the back and get individual help on anything. So it's a really good, it's a good blend. Tomorrow morning I'll play the game again, 6:30 to 7:30. After school I can't stay tomorrow. Saturday didn't work out. My son-in-law is really excited about having a family paintball tournament. We're all a little nervous since his son is he's a member of the Army. So a little nervous. So yeah, he's a little bit skilled in these types of. I've heard of this before, where you show up to play paintball, and like if you show up at the wrong time, some like SWAT team shows up at the same time. It's like it's just a disaster. It's like, why did they even come? And 2 seconds later, we're all dead. So anyway,
have knowledge against them.
Yeah, I'm afraid to
find the derivative.
Find the derivative and dodge.
Wish you would have. Okay. So anyway, I won't be able to come Saturday, but I'll hit it hard again next week, as much time as I can. Any questions about the test on Monday? Is it time? It's time. But because you have the answers ahead of time, I'm not sure it will matter. Like I'm thinking you should be able to get done within the period. But you can use the full time if you'd like. All right, so skipping the first problem, let's go to the next one. Okay, you've seen the, I'm going to leave this kind of small print just so I can write on all of them, but you have it in your hand. Okay, you've seen all of these questions before as well. They showed up on an FRQ, either practice test or the actual test that we took at the beginning of February. So these are not real new either. What we're going to do is you're going to look at your scoring guide. So look at problem number 2A and read the answer to yourself. Everybody read it, and then just hand it if anyone has a question. If the answer doesn't make sense, it's hard to memorize. If the answer makes sense, it's easy to memorize. So as you read it, if it doesn't make, it's our calculator, right? So the first 3 on this test are calculator loud. Yes. So does anyone have any question about part A? Like I don't want to add to the scoring guide if you're like, oh yeah, that'll make sense. I want to get to things that maybe don't make sense. Do you have any question about how to answer A? Please, Jeff.
For the decreasing, increasing, it's if they're opposite, then it's decreasing, same, increasing, correct?
Perfect. So whenever they ask me if the speed of a particle is increasing or decreasing, I check the velocity and acceleration at that time. Signs are the same, speed is increasing. Opposite, speed is decreasing. Perfect. Please, Barry.
You say at that time, so we find the derivative twice, basically with 2, like it has 2.
Well, we wouldn't find the derivative twice. We find v of t, so we just plug 2 into the velocity.
Okay, we already have the velocity.
Yeah, we got that.
And then we find it again.
Find the derivative, plug in 2, so you've got the velocity and the acceleration.
Signs are the same, then it's speeding up, but if it's not, then it's not.
Yes, perfect.
Wait,
Chad, go ahead.
did you say you plug in 2 with the velocity originally and then plug it in with?
You have to identify both the velocity and the acceleration. So you notice on the scoring guide they're finding both of them.
Yeah, but I think the velocity,
Velocity prime.
yeah, velocity times. You only plug in the 2, then you don't plug in the velocity. Okay.
No, you need to find both. Chad's chart. So they're doing that.
Oh, yeah.
Yeah, it is Chad's chart.
Everybody,
Chad's chart.
I just read the first part of the question. No, I just read the first
You're
part.
okay. So hey, On the test, look at it. If you want the points on the test on Monday, you must have written down the actual velocity. Like, I want to see a number. Don't memorize that little formula. Like, give me a number. Okay? And then give me a number for the acceleration. And then just say what Jackson said. If those two signs are the same, the speed is increasing. If those two signs are different, the speed is decreasing. Good question. Any other follow-up questions on A? Okay, part B says find all times in the open interval when the particle changes direction. Read what they wrote. That's kind of hard to understand what they said. Let me say it to you in English. Okay? It's really pretty simple. The sign, and write down anything you want to write down now. Like if you'll memorize what I say, it's a lot easier. The sign of the velocity indicates direction of motion. The sign, like what they wrote is a bit hard to follow if you ask me. The sign of the velocity indicates direction of motion. The sign of the velocity indicates the direction of motion. Pretty good with that. So when they want me to figure out when the particle changes direction, I need to graph velocity on my calculator and just pay attention to when the velocity is changing sign again. Before I was comparing, acceleration of velocity changing sign. I just want to look at when the velocity is positive, I'll know the particle is going to the right. When the velocity is negative, I'll know the particle is going to the left. I just write something about that. In this particular problem, the graph ends up looking like this. This is the graph of the velocity. So I simply could have written from time equals 0 until time equal, it turns out to be 2.507. The velocity is negative, so the particle is traveling left. From time 2.507 to time equal 3, the velocity is positive, so the particle is traveling right. Therefore, the particle changed direction at time equal 2.507. That's what I would have written on the test to get full credit. Does anyone need me to say that again? So, from time equals 0, I'm going to watch your pencil, make sure I don't go too fast. Time equals 0 to time equal, you'll have to find this on your calculator, 2.507. The velocity is negative. So v of t is negative. So particle is traveling left. And you don't have to write all the words. You can kind of be cryptic in the grammar. They don't care. Like you can use v of t to represent velocity. Any g for negative is fine. Then from time equal 2.507 to time equal 3, v of t is positive, so particle moves right. Therefore, particle changed direction at time equal 2.507. Follow-up question. Please, Sora.
I just don't get, because on ours it says that v of t equals 0 when t squared over 2 equals pi. Like I don't get where they're giving that from. Like I get what you're saying, how like it switches at the 2.5, I just don't get where that.
Oh, so what they're doing is they're solving it without a calculator. You don't have to worry about that. When they make up the scoring guides, whoever makes them up just kind of decides how he wants to do it or she. There are other ways to do it. Since it's calculator allowed, you can ignore that. Okay. Yeah, you literally can graph velocity on your calculator and then just find that point. Okay. That's plenty good. Okay. So the steps they have on the scoring guide where they say what you read, and then they've got t is equal to the square root of pi, none of that is necessary. Okay. Good question, Sora. Anybody else? Please.
So to answer that question, oh wait, never mind.
You good? Cool. Anybody else on part B? Okay. Part C says find the total distance traveled by the particle. Look at the answer for part C and just raise your hand if you have any question about that. That's a golden opportunity to get 3 points really easily. question on part C. C is very straightforward, it's simply about integrals.
Yeah.
Again, note on the scoring guide, they're going to want the limits, the integrand, and the answers. So make sure you write them all down. So, okay, part D.
Wait, can you
Okay.
remind me why it's absolute again?
A good way to remember it is this. If I'm the particle and I go to the right sum and then I go back to the left sum, if I want to know where I end up, answer this, Ellie. Was my positive movement, was the positive and negative part of my movement, like the sign was important. Like I go to the right sum, I go to the left sum, it's important that I keep track of whether I'm going right or left. So being positive and negative is important. So I don't want absolute value when I'm trying to find my position. If I want to just know how far I really traveled, I really could have just said, well, I went this far to the right, and then I went to the left, but I went this more to the left. So I can just ignore the sign and just basically add up all the distances. Okay, part D. Look at me, please, everyone look up. I want you to take notes on this one. What they have in the scoring guide to me is hard to follow. What I show you is an easier way of memorizing the problem, and it also applies more easily to future problems. So what I would write down is this. They ask for, it says, in the time interval 0 to 3, what is the greatest distance between the particle and the origin? Okay, really asking for the greatest distance is asking for when the particle's position is either most positive or most negative. Because if I'm the particle and I have a position that's way over here positive, well, I'm far from the origin. If I go more positive, I am further from the origin. But I can also be far from the origin on the negative side, way over here. So it just wants to know when my position is either most positive or most negative. It wants to know when my position value is either greatest or least. So really what's being asked, I'm going to write this down. So we're supposed to find greatest and or least value of x of t. And anytime I'm trying to find the greatest or least of something, I always study the derivative of what I'm trying to find greatest of. So now I'm really focused on x prime, which is v. So all my focus is going to be on x prime or v. And what do I focus on? I got to go find out when x prime is equal to 0. Because when x prime is equal to 0, x has critical points. There's another question about that. This is review. Whenever x prime is equal to 0, x will have critical points. So this is equal to 0 at, we already found it earlier in the problem, t equal 2.507. Of course, I store that so I don't have any rounding errors. Questions so far? So now I know that the particle is going to be at its greatest value, sorry, the position is going to be at its greatest value or least value at one of 3 times. 0, 3, or this time. I know for sure that's when the particle will have its greatest position value or least position value. That's when the particle will be first. Please, Chuck.
What's the graph there? Is that the graph of velocity or the graph of x?
Velocity, good question. So this is my graph of velocity, or x prime. And that's what I study when I'm trying to figure out where x is greatest or least. It's perfect. 2 for a chat. And
Is it like, oh my gosh, my mind.
you're fine. We'll come back. We'll come back in a second. Anybody else? Happens to me all the time. Okay. So now all I'm going to do is find the value. So I write down my paper this. X of 0 is known to be 1. I can find x of 2.507 using an integral, because I know if I integrate the rate at which the position is changing, that's called velocity, that integral will tell me by what amount is the new position different than the old position. So I go from time 0 to 2.507. The integral tells me by how much the position changes. I add to that what the position was, and I get the new position. It's written on the scoring guide. What does it say? Say it letter different. 2.265 negative. Questions? They don't do this on the scoring guide. They give a different answer, but I don't really like it. To me, it's hard to understand. So what I would do is just one more integral. I would go find x of 3. Once I have that, I can write a concluding statement that simply says, therefore the particle is farthest from the origin at time 2.507, where the position is negative 2.265. So the greatest distance is 2.265. Follow-up questions, please, Jeff.
Would they be upset or mark it wrong if you kept the negative when you said the greatest distances?
I would hope that they would be forgiving for that. That seems like such a trivial thing. Safest is to leave off the negative, because they really are talking about distance. Good question.
2.265
Away from the origin. It just happens to be on the negative side. Please.
So when we're talking about
Two
distance,
for Jackson and also Darren.
distance away from the origin is on the x-axis, not the y.
Yes.
So this is going to be in the middle. I'm trying to ask that.
No. It doesn't really matter, Mikkel, whether the particle is going back and forth along an x-axis, or if it's a car moving along a road, or if it's a balloon going up and down, or if it's a particle going up and down. That doesn't matter at all. What always is true is that if I want to find out, let's try Danica's chart here. This is your question, really. So for this problem, the Danica's chart that I'm working with would look like this. We have position. If I want to find the rate at which position is changing, I take the derivative, I get velocity, or x prime. But if I want to find out how much this has changed, I go this way. If I integrate velocity, I can find out how much position has changed. And that's always true. So what I'm doing here is I'm saying, I have the velocity, so this integral is going to give me a number. That number is going to tell me how much different is the new position from the old position. So I can tell from the computations here that this number, the integral's value, must have been negative 3.365, which tells me that during this time period, the particle was somewhere, and its new position is this much to the left of where it currently is. Hence, since it was at 1, its new position is here. I'm not sure that answers your question.
Yeah, but I have a little bit.
Keep going.
So how did you just pick 2.507? Because they gave it to you?
No. So what I did is I remembered a fact, which is if I'm trying to find when anything has its greatest or least value, anything. In this case, I'm looking for when position has its greatest or least value. That's always going to occur either at the beginning time, 0, this is coming back to you now, beginning time 0, the ending time 3, or any of the critical times. Well, x has critical times when x prime is 0. So I went and drew x prime on my calculator, velocity, and discovered that right here, time equal 2.507. That's when velocity is 0. That's one of the critical times for position. That's why I used it. Does that make sense?
Yes.
Good.
I'm just confused on why the answer is the B position is the greatest distance. Is that the answer?
You said it louder, sorry.
Is the B position the greatest? Is that the answer? Because that's what it kind of says on the scoring guide here.
You gotta say it one more time, Sarah, sorry.
The 2.265, isn't that the B value? It's like it's saying that the middle part is,
The B value?
because you store it as B.
Oh, got you. It is the value we stored in B. That's the time.
Yeah, but is that the greatest, like, distance?
No. Sorry. What you would write on the paper to get the final result is this, Sarah. So you do this work, you're okay with that.
Yeah.
Then you would write this. You'd say, therefore, let's see what the question is. You're in the time interval, what is the greatest distance? You show the work. Therefore, at t equal 2.507, the particle is at its greatest distance from the origin that is really bad grammar. 2.265, I would probably write it again.
Is
I have
it
a
just
second
because
chance.
it switched direction, that's why it's right there? Because when I do the integral for x of 3, then that number, that value is bigger than this one.
What number did you get? Did you add 1 to that integral?
Well, yeah, and it's 5 point something.
It should be negative. It's negative.
Yeah, something went wrong with the computation.
Wait, when did you integrate x?
Sydney, did you do this one?
Yeah, I got negative 1.197.
Yeah, that's right. So that was just some sort of mistake.
197.
That's why it's not making sense, Sarah. Did you integrate out? Did you get it
Yeah,
now?
I get it now.
Sarah, you good? Are we good to there? Any follow-up questions? 2 pebbles for Sarah, 3 questions. Kelsey?
On the grading thing, what is the 4.34?
Yeah, I don't like that explanation. To me, that's hard to make sense of. If you do it this way, you'll get full credit. It's easier to make sense of in my opinion. So I'd rather just leave that one. It's a good question on 2 pebbles. Please, Joe.
I don't think it matters like a ton, but so since you're adding 1 because that's the time that's the position at time equals 0, couldn't you just like technically whatever value is highest, whether that be positive or negative, would be the farthest away, if that makes sense?
It is. No, that's exactly right.
But one's just to like know exactly where it is.
Oh,
Is that-
no, that actually can cause problems. That's a good
Yeah, that's
question.
just- yeah.
That's a good question. Watch, hey. Yeah, here's what you're thinking. Watch this. I think this is your question. See if I make sense of it.
Yeah.
So, okay, if I just do the integrals, I only find change in position. I don't find out where the particle really is.
Yeah.
Um,
Are we considering the origin one though, or is
No,
it
memorize origin always means location
Okay.
0. Always. Yeah, the original place where the particle is 1, but origin always means location 0.
Yeah.
Does that answer your question?
Yeah, that answers it
Okay,
right
so you're
there.
good. Please, Randy.
So is this just like a math problem?
It is. It's exactly. It's just finding the greatest, least, max, minimum, some value. In this case, it's the position that you're finding the max and minimum. You know? Next one. Okay, look at the answer to A, like study it closely, and see if anyone, I think A is straightforward. I'm hoping that you can look at the scoring guide and know, like make sense of the answer. If not, please raise your hand and ask about it. Anyone? Please, Todd.
No, like when they say like find the approximation, like, did it matter which reading you were supposed to leave?
So on part A, they're not doing a Riemann sum.
Oh, it's just a slope map.
Yeah, part A, they're doing a
Yeah.
secant slope.
Okay.
Because the question is saying find, so this is R. Yeah, well, you gotta know, y'all just say it since I started. So R prime is the instantaneous rate at which R changes. And they're saying go find that instantaneous rate or instantaneous slope. And you can't really do that. Like here's a graph of R. They want you to find the slope right here at 45. I can't really do that without a formula. So what we do instead is we find the nearby secant slope and call it a good approximation. And that's what they're doing on the scoring guide. Good question, 2 for Todd. Anyone else? Please, Derek. Say again. So to find the secant slope of r, so r prime means the tangent slope of r.
Yeah.
Oh, you need me to sign something.
Yes, thank you. I forgot. Thank you. Okay.
How are you?
Good, how are you?
Haven't been to class all week, so I haven't seen you.
Oh.
So what I do is I say this, Derek, r prime of 45, the instantaneous rate at which r is changing, is approximately the same as the nearest secant slope. So the nearest secant slope is going to be r of 50, subtract r of 40, all divided by 50 minus 40. And then I just plug in the number. Plug in the value. Okay. For Derek, anyone else?
Well, I think it's divided by 50 minus 40.
So R itself is a rate already. So the numbers I get here, R of 50 is going to be 55 gallons per minute. So I'll kind of put that as just G per minute. Minus 40 gallons per minute. Okay, I'm running out of room here, but the distance between those is 15 gallons per minute. So that's not a rate. That's how much the rate changes during that time period. If I then divide that by the time period, 10 minutes, I get basically this number, 1.5 gallons per minute every minute, which is a rate at which the rate changes. That's why you're dividing.
So that's on this one, it's rate times time equals amount, but you're solving, where you're using all the measures.
Yes, very good. Super Deborah and Jackson. Anyone else? Anyone else on part A? Okay, there's not a lot of room here, so I'm going to erase this and start over. Okay, part B, listen. If you want to memorize the answer to part B and get the points on the test on Monday, I'm fine with that. We're not going to talk about it in class because this is one of those questions where you spend way too much time trying to figure it out. It's not worth it. I'm dead serious. Like, you want to get good at easy and medium problems before confusing ones cause you trouble. So this is one of those where I go, hey, it's only a couple of points, so I'm going to worry about it for now. I'm going to go over here to part C. So look at the answer to part C. The first part of C is to find a Riemann sum, left-hand Riemann sum. Make sure that makes sense to you so that you'll be able to do a Riemann sum from memory. Does anyone have a question? Please, let me just
Do a tiny bit of it.
So how I would start, you're good, as I'd say I got to do the integral from 0 to 90. And the integral itself reminds me what to do. It's an approximation here. I'm supposed to take some value of t, plug it into r. Some value of t and plug it into r. So, so I got to divide up my, this is 5 subintervals, so I go, okay, so starting here, we start at time 0, go to time equal 90, divide into 5 subintervals. So I look at the first subinterval, I go to the left. The left of the first subinterval would be time equals 0. That's the time that I plug in. And then I multiply that by the change in time, which would be 30. Plus, I do it again for the next subinterval. The next subinterval, the time on the left is 30, but the width of that subinterval is only 10. Okay. The process is the same for a right hand, midpoint, trapezoidals where you add them and divide by 2. In the left and right, add and divide by 2. For Derek, question? The next question, the next point available is easy. It says, is the numeric approximation of the integral, is the numeric approximation greater or less than the integral itself? If you look over here at r, if you look at the graph of r, it's easy to see why the approximation is actually less. if we were doing the integral perfectly, it would be taking values of r times short amount of times repeatedly for every single value of r. So you would be taking little teeny rectangles like this. So the integral would be perfectly computing the area that you see below the curve. Questions? When we do the approximation, that doesn't happen. Because all we did was take, we lost Chad. All we did was take r of 0. R of 0 is here. The change in time is 30. Those two multiplied together give you a rectangular area, which is less than the ideal computation. So all,
If it's right.
yeah, that changes. Very good. So on this problem, what I would write is, since r of t is increasing, the left Riemann sum is an under approximation. If r of t had been decreasing, the left Riemann sum would be an over approximation. If r of t is increasing, the right Riemann sum is an over approximation. If r of t is decreasing, the right Riemann sum is an under approximation. Chat, please.
Will they ever ask that question, but with like a trapezoidal?
They will on trapezoidal. They won't on midpoint. For trapezoidal, it's easy as well. If the function is concave down, then the trapezoidal will cut under. So the trapezoidal will be an under approximation. If the function is concave up, trapezoidal is an over approximation. That's the way you answer those questions. Please, Sarah.
That does not make any sense.
For which one?
The
You're fine, just keep talking.
how, just the whole reasoning behind if it's like increasing, or if it's the value that is bigger than that.
You're good. Let's go here for a second. So here's the idea. If I have a graph, and the graph is increasing, and if I were to do the actual integral, the integral would compute the area perfectly. Are you okay with that?
Yeah.
Good. If I do a left Riemann sum, though, I'm going to go to the first subinterval, and I'm going to pick the left side. And the value of this function on the left is what I'm going to multiply by this change in time. So this dimension multiplied by this dimension produces the area of the rectangle, which is less than the actual area. Hence, if the function is increasing, and you're doing a left Riemann sum, you get an under approximation. If that makes sense. If not, just say, no, it's fine.
I don't know. I think I just have to like think about it.
You're
And
good.
then,
So just do one little thing at a time. So are you comfortable with the idea that if you did the integral perfectly on a calculator,
yeah.
that it would find the area I'm about to highlight? You okay with that?
Yeah.
So this is the function f. And if I integrate f
But, like,
from
why is
whatever
it-
it is, it's going to be perfect.
Why is it so important that it's left Riemann sum?
Oh, because if I had the same situation, so let's say it's the same function basically. The function's increasing. Okay with that? And I do a right Riemann sum. Now what happens is you go to the first subinterval, like this much, but you go to the right of the first subinterval, and you pick the value of the function on the right. That value, this length,
Oh, okay, yeah.
yeah, so that's why if I'm doing a, if the function is increasing, and it's a right Riemann sum, I get an over approximation. Is that better, Sarah?
Yeah.
Good. That's all I'm saying. You okay with that?
Mm-hmm.
The last one, since we started down this path, was this. If you had a function that was, say, concave down, and you do a trapezoidal approximation, so you go to the subinterval like this, With trapezoidal, you actually take the left and you take the right. And when you add those together and divide by 2, you're actually finding the area that would fit inside that trapezoid. So that's why if the function is concave down, and you're doing a trapezoidal Riemann sum, you get an under approximation.
Okay.
Is that good? 2 more for Sarah. Anybody else? So back here, that's it for this one. Okay, look at number 3. There's some keywords you should underline. The keyword on number 3 that you should underline is the word gallons and the word minutes in the first explanation. If you don't have the word gallons and you don't have the word minutes, you won't get the point. So the first explanation, you must include the word gallons and the word minutes. In the second explanation, and so the other keyword really is R of T is the rate at which fuel is being consumed. So when I integrate R, I'm calculating how much fuel was consumed in gallons. I'm not getting a rate anymore. I'm using a rate to find an amount. When you integrate the rate at which fuel is being consumed, you find out how much fuel got consumed. Then, on the next one, you're taking that amount of fuel and you're dividing by time. So you're going back to a rate, but it's an average rate. We've talked about that, how you can integrate something, divide by the width of the integral, and you get the average of that thing. Well, we're integrating the rate, and then we're dividing by the width of the integral, so we're getting the average rate of fuel consumption in gallons per minute. The units have to match up perfectly with the words. Does anyone want me to say anything more about getting points here? Like, this one you gotta be careful. If you don't write it out correctly, you won't get the points. It's gotta be like clear that you're understanding the difference. Questions? Next one. Go to 4. Okay, number 4. Read answer A, please. Read answer A. Raise your hand if you have any question about A. A is 2 easy points. You have a question about A? Read A, please. Any questions on A? Sorry?
For the answer, did you have to put the time intervals in the right, or could you just read it?
You're good. So the question says, on what intervals is F increasing? So you do have to specify the interval. So you say, on this time interval, F is increasing because F prime is positive on that interval. There's different ways you can say it, but you must include the appropriate time interval. You must say something about it's because F prime is positive on that interval. Anyone else? Here's what I would write on B. I first think to myself, I wouldn't write this. Any function has a point of inflection when that function changes concavity. Any function has a point of inflection when that function changes concavity. That's what I would remember. Any function has a point of inflection when that function changes concavity. What I would write down is F has a point of inflection at, let's see, x equals 0. And x equal 2, because F prime changes from decrease to increase, and then from increase to decrease at those points. And that would give me the full credit. You need me to say it differently, say it again.
Please say it one more time.
So I would write F of x has a point of inflection at x equals 0. Watching your pencil, and x equal 2, because F prime changes from decrease to increase, because F prime changes from decrease to increase, and then F prime changes increase to decrease at those points.
Thank you.
You're welcome. Two for Lindsay. Anyone else? Please, Ellen.
If we just like abbreviate,
You can abbreviate, yeah, you can abbreviate increase and decrease as INC and DEC. You can also abbreviate positive and negative as POS and NEG in their file. I think you can, but it looks kind of funny sometimes, so I prefer to write positive and negative, but I think they're okay with that. Please, Derek.
Kind of going back to part A, I know it's really simple, but it's just asking where's the increase, where's that increasing, so at prime basically, where does it change from positive to negative? Or
Well, in this case, we don't look for a change really.
not change, just where
Yeah.
where's the positive? So in the answer, how would we write it?
Here's what I would write. You're good. The answer is sometimes hard to deduce. I get it. I would write F is increasing for X equal, F is increasing for X equal -3 to X equal -2 because F prime is positive on that interval.
Okay.
That's what I would write. What else? It's all good.
I'm sorry.
You know, you probably wasn't bothering me at all. It's just Mikhail started laughing so much.
Why are you laughing? I'm laughing.
Jeez. Glad they found you, Chad. I was a little nervous there. Are we good? Sweet. Inside joke. Okay. Brady laugh. Find an equation line tangent. Okay, look up. Hey. Find an equation line tangent to the graph of F at this point. Here's what I would do. I draw a picture to remind me. I'd say this is F. I have no idea what F looks like. You know, the point they're interested in is the point 0, 3. And then I would remember something really important, and that is the slope of F at x equals 0 is F prime's value at x equals 0. Chad, please.
Like, I don't think the, like you said, the picture doesn't matter, but we only kind of know how the graph would look because it's like X chart, and we already have a picture of that.
Oh yeah, for sure. You can take the time. So this is just my memory aid. That's all that is. Yeah, it's a good question. Two troubles. It's not meant to be what F looks like. It's just how I kind of remember it. Anybody else? We have trouble with this statement here. Slope of F at x equals 0 is F prime of 0.
Yeah, I just meant like envision, I guess.
That's just the meaning of F prime. Remember we talked way back in October that every y coordinate on F prime represents a tangent slope of F. Every y coordinate on F prime represents a tangent slope on F. So I know that right here, at x equal -3, let's see, that y coordinate is 1. So on F, the tangent slope at x equal -3 is going to be positive 1. I know that at x equal -2, on the graph of F, the tangent slope will have a value of 0. You can read the slope of F by reading the graph of F prime. Please, Michelle.
So without them giving you an equation of F, how do you know F's slope?
So if I want to find the slope of F, I've got to have some information of some type. If they give me an equation of F, I can take the derivative and use that to find the slope of F. Here they just gave me a graph of it, so I can use that. They have to give you something. So now you can just write down the answer, because look, F prime of 0 is equal to -2. So the answer is y equals the slope, -2, x minus the x coordinate, which is 0, plus the y coordinate, which is 3.
Oh, is that the line equation?
That's the equation of any line.
Yeah, can you just write that without any numbers, just like?
Yeah, the formula.
Yeah.
Question? Please, Derek.
You always plug the x coordinate into the second, it's x minus x1, right? And so you plug it into that.
You technically can plug it into either of them.
Okay.
Like, I have to be honest with you. Like, I could have put a 0 here and a 3 here and the slope of -2 here, and it's still correct. But on a multiple choice question, they won't do it that way. They'll always put the x coordinate and the y coordinate.
Okay.
Because this x1, y1 simply represents any point on the tangent line.
Yeah.
This simply represents some other point on the tangent line. So you can plug it in either place.
But they're related to each other.
They're just in the sense that they're both on the line.
Yeah.
Kelsey?
Would they want you to reduce that more, like?
Great question. On an FRQ, no. One of the rules of an FRQ test is algebraic simplification is not required.
So you could do it.
You could, but I wouldn't, because if you have this and then you make a mistake, you're going to lose the point. So don't take a chance, just leave it. Anybody else? Awesome. Okay, last one here. I'm not sure what the scoring guide says. The scoring guide is helpful, but let me talk through it. Okay, it says find f of -3. Well, I remember something we just talked about. That if I integrate, say from, let's go from -3 to 0, f prime. Okay, if I integrate from -3 to 0, f prime, the integral will compute how much f changed from -3 to 0. How much f changed from -3 to 0. Everyone comfortable with that? Okay, that's not new. We did it earlier when we said if you integrate the rate at which position is changing, you find out how much the position changed. Okay. If you integrate the rate at which oil is flowing, you find out how much oil flowed. If you integrate the rate at which the plane is consuming gasoline, you find out how much total gasoline was consumed. Okay, we don't have any equations though. However, because we can use integrals to find areas, we can also use areas to find integrals. So to do this integral, here's what you do. -3, draw a line. X equals 0, draw a line. F prime of x is already drawn. And dx is basically representing the x-axis. So the area that gets surrounded by those things is these little areas here. So we've got this area in here. Highlighter. So I've got this area, and I've got this area. Okay. The orange area gets counted positively, the blue area gets counted negatively. Because when the integral is actually computed, like on a calculator, what the calculator would do is it would plug in -3 into f prime, it would find this value. It would then multiply that positive value by some small change in x, then it does it repeatedly. So from here to here, all the f prime values are positive. When the calculator is computing that integral, it's just getting positive values. But for the rest of it, the f prime values are negative. That's why the blue area gets counted negatively and the orange area gets counted positively. Questions? Now I just compute area. This triangle is 1 by 1. 1 times 1 is 1. But because it's a triangle, it's half of that. That area is 1/2. It's counted positively. The blue area is 2 by 2, 4. Take half of it again, that's 2. That gets counted negatively. Therefore, from x equal -3 to x equals 0, the graph of f, whatever that graph looks like, draw it over here for a second. So we don't really know what f looks like, other than we know that at time equals 0, f is equal to 3. So the point on f here at 0, 3. And from x equal -3 over here to 0, f went down by 1.5. So what must have been the value of f at time or x equal -3? 4.5. Questions?
Can you explain that last?
I can see the look on your eyes. No one is daring. I'm glad you spoke up. Good man. Speak up with this. The look in the class was like, what? Okay, when you integrate f prime, you find how much f changed. So does anyone need any follow-up on the fact that this integral's value is -1.5? Buddy? Please.
Did you say that how much f changes or f prime changes?
F changes.
Okay.
Now that's always been true. When you integrate f prime, find out how much f changed. It's like when you integrate x prime, you find out how much x changed. When you integrate the rate, you find out how much the amount changed. So, Braden, from x equal -3, look at the graph here, until we get to x equals 0, f's going to go down by 1.5. When we get to 0, the value of f is 3. So what must the value of f have been when we were over here at x equal -3? Well, 4.5.
So the reason we're,
Go ahead, Jackson.
why is the value 3 at 0? Is it because of earlier in the question?
Right.
Is it because of c?
No, just right here.
Oh, does it say at the top?
Yeah. No worries. So in the problem itself, they stated
Oh, okay.
that. Yeah, good question. Bring it out. Easy. That makes sense. All right, good.
I think I'm just missing something. But so like, since we integrated that prime, like, I'm just confused. Like, it seems to me like you're going in a straight line from -0 to 0. You know, it's just
No, it's. I don't know
That's what
that.
it seems like. I can't picture like one straight line to like get you on negative, right?
No, it's a curve of some sort. I can't see it either easily. Oh, all I know is this. The value here is 4.5. So it's -3, 4.5. But it doesn't mean f does this.
And I just don't know why.
Oh, that's okay. Hold on. Does this value make sense to you?
That value makes sense.
Don't worry. So, what's the value of, so this is like, you know, it's not a time period, but maybe you think of it as a time period, maybe it's easier. So here's a time period, from -3 to 0. So the end of the time period is time equals 0. At that time, what will the value of, not f prime, but what will the value of f be? 3. And only because they told us. Good with that? Okay. Think of it this way. The integral of f prime is computing how different f is from the beginning of the integral to the end. So from the beginning of the integral to the end, f is 1.5 less than what it was. You're welcome. Anyone else? Pretty good? Okay, to find f before it's similar, you would do an integral from 0 to 4 would be a good choice. Okay, now it's a little different shape. Oh, Jeff, please.
Just real fast, like if they, let's say they give us the point, instead of like 0, 3, it was like 1, 3, would you want to do the integral from point 1?
Yeah, it's very good.
You
Hey,
just go right
oh yeah, super chat, listen. The question is very good. The whole reason I picked the integral from -3 to 0 is because I know the value of f at 0. Otherwise, it wouldn't have held. Like, I can use the integral to find out how much f has changed, but if I don't know what f was at one of these 2 times, it's not going to help. So, there's another way you can do it. Maybe, I don't know if you like this way better. You can say this. Maybe some people prefer this method. The scoring guide will do it this way a lot. The integral from -3 to 0 of f prime is how much f changed. But the other way to write how much f changed is to simply do a subtraction. Just write down, well, how much is f changing from -3 to 0? Well, take what f is at the end, subtract what f was at the beginning. That difference has to equal this. That's what we mean by the change in f. So this integral turned out to be -1.5. f of 0 is 3. Some number has to fit there to make this a true statement. That number's got to be 4.5. Questions? Cool. Okay, back here, the next integral is this one. We're starting at 0, going to 4. We're integrating f prime. So the area we're concerned about is here. So all of the area this time gets counted negatively. Okay, it's an old geometry problem. You probably did it in 6th grade. You find the area of this shape, this rectangle, which is 4 wide and 2 high. So the integral of f prime. It's going to be all negative, so let's put a negative here. So I take the area of the rectangle, that's 4 by 2, that's 8. And I subtract away the area of this semicircle. Okay, well, we just talked about how the area of the semicircle is pi over 8 diameter squared. The diameter of that semicircle is 4. Like that. That's how much f changes, that weird number. If you want to keep doing that, you can say, let's see, that's 8. That's going to be 16 divided by 8 is 2. So it's 8, so it's negative 8 minus 2 pi. That's the value of the integral. So starting at time 0, f was already 3. From 0 to 4, f changes by this amount. So the new value is, we would say f of 4 is equal to the initial value of 3, this much of a change, so minus that thing. And you can just leave it like that, because there's no calculator on this section. Questions?
Like, why couldn't you simplify like 3 minus 8?
Oh, that part you could. You don't have to actually, though. No, that's a good comment. So I could say that's going to be, let's see, that's going to be -5. The negative will make that positive, so a convenient way to write it is like this. Please, Maddie.
On the square rubric, it says 2 squared and you said
Oh, so they did the formula, they did 1/2 pi r squared. I just used that other formula we've been using, pi 8 diameter squared. The result is the same. You can use either one. So good question. 2 for Maddie, 2 for Brady. Anyone else? Oh, please, Haley.
for the interval of 0 to 4, did you have a negative a to b minus c and negative from the
Let me do it with different numbers. I think it'll make more sense to you. So, how do I say this? We know that, let me get some space. Hold on a second. Your question's really good. Do we know that f of 0 is what value, Haley? 3. The integral tells us how much f changes. So the integral itself, is the value of the integral going to be a positive or a negative number, Haley? Sorry, will the value of this integral, ignore all the computations, that's just getting in your way. Will the value of the integral be positive or negative? We know it's negative because all of this area is below the x-axis, okay? So that means the value of f at 4 has to be something less than 3 because the change was negative. So basically I'm saying take what f is, and how much does f change by? It changes by this weird number. That's the value of the integral. So if you can either add that negative number if you want, like that. That still didn't help. I didn't do a very good job on that one. Try it this way. 0 to 4. That's equal to f of 0 subtract f of 4. Are you clear with that equation? I want to find out what f of 4 is. So but just think of this as one big thing equals one thing equals another. So I want to solve for f of 4. What would you do first to solve for f of 4? So we can do the integral. The integral turns out to be this value that's a little bit weird. Are you okay with that? Good there? This is equal to 3. What would you do now to find out what f of 4 is equal to? I just think of this as x. So I minus the 3 over here. We're doing just great on this. So that's going to give me negative this weird thing. Minus 3 is equal to negative f of 4. And what would you do? Divide by negative. Which is the same thing as multiplying this by a negative 1. Dividing by negative 1 is the same as multiplying by negative 1. Disagree? What's 5 divided by negative 1? You good there? So when we move the negative over, this becomes, maybe you had it right, maybe I'm messed up. I'm me confused.
Sorry.
What is the answer on the paper? I thought I had it right.
Negative 5 plus 2 pi.
Negative 5 plus 2 pi. The value of the integral is negative. Oh, this is backwards. Nobody caught the mistake. Look up.
Yeah.
Yeah, it's always got to be top minus bottom.
Yeah.
Ooh. Game over. Game over. Oh, it's only March 23rd. I'm not worried. March 8th, I might be worried.
March 8th.
May, yeah, March 8th is shoot my dollars. Fetch my dollars. Oh yeah, fetch my dollars. He says shoot my dollars. Shoot my dollars.
Never said.
So this should have been f of 4. We don't know. This is 3. So now it's, when you add the 3, oh, it becomes a plus 3 on this side. Does that make sense? Sorry about that. Okay, study 5 and 6 as well. The test is on the whole packet. So.